All right, so again, when we're graphing something, we have to determine what do we know about the graph. There's not a lot that we know right away, but we know that it can't be 0. X cannot be 0. Excuse me. X can't be 0 because then we would be dividing by 0. So we have a vertical asymptote right there. And then there's another problem. We can't have the square root of a negative number. So if x is bigger than 1, we have 1 minus something bigger than 1 is going to give us a negative number. So for example, if we plug in 2, we get square root 1 minus 4, which is square root negative 3. That's not okay. So I think we can see that our graph is only going to exist between 1 and negative 1. 1 and negative 1. Again, because if we plug in a negative 1, or a number bigger than negative 1, like negative 2, we get a positive 4 again, which is 1 minus 4, which is negative 3. Okay? And then at 1, it's going to be 0. And at negative 1, it's going to be 0. So now we just have to figure out, we know we can't be bigger than 1 or smaller than negative 1. So now we have to figure out what happens as we approach 0 from both sides. So we're going to take a limit as x approaches 0 from the right, and take a limit as x approaches 0 from the left. So up here, as x becomes really, really small, as it gets really close to 0 from the positive side from over here, we have a positive small number, and then on top we're essentially going to have 1. And 1 divided by a really small number is going to be really big, so we're going to have something like this. All right, and the same situation over here, except it's going to be a really small negative number, or a number close to 0 from the negative side. If we divide by a really small negative number, then we're going to shoot down to negative infinity. So there's the rough shape of our graph. Let me pause for a second, find the original trig function. Okay, so it was tan arc cos of x. So our original function was tan arc cos of x. So then we have to think about excuse me, what happens when our x value is getting closer and closer to 0. Well, what this x input is it's a ratio of the adjacent to the hypotenuse. So as that ratio becomes smaller and smaller and smaller and smaller, what's happening is, in our triangle, the adjacent side is small compared to the hypotenuse. Okay, so here's our adjacent side, and it's pretty small compared to the hypotenuse. That's what's happening as x goes to 0. And then we're taking the tangent of that. And tangent, we know, is slope. Tangent of our angle is really just slope of our hypotenuse. And our slope is becoming bigger and bigger and bigger and bigger as this adjacent side becomes smaller and smaller and smaller until it hits an undefined infinite slope. So that's what's happening here. And then as this becomes closer to 1, right, as we get closer and closer to 1, well, what's happening is the hypotenuse and the adjacent are basically the same because, again, we already said this is adjacent over hypotenuse. If that's becoming close to 1, then what's happening is, in a triangle, the hypotenuse and the adjacent side are going to be almost the same. Well, what's happening to the slope when that occurs? It's becoming smaller and smaller and smaller until it's eventually going to hit 0. It's a 0 slope. It's not even a triangle anymore. Now it's just a very straight, neat line. And that's when our slope is 0. All right? And then the same thing is happening over here. So when you write, you need to write something about how this input changing affects the slope of the hypotenuse in a triangle. And that's how you should explain the shape of this graph.